Hey, what's up everybody? Joel for divisionof8.com. Today's tutorial we're going to be looking at creating a Plexus type particle effect in 3ds Max using thinking particles. The result is we're going to end up with something like this here. So we got this kind of cool, weird organic particle action going on here with some boxes and some lines stretching between them. The inspiration from this came from a plugin for After Effects called Plexus. If you don't know what Plexus is, I've got a little video here kind of showing you what it does. It's this great plugin for After Effects that allows you to create little points in 3D space here, and then based on distance thresholds and whatnot, it creates these lines between the particles, which creates a really cool kind of organic animation that you can kind of see here going on the screen. So I really like the look of this, and I wanted something to throw at the beginning of my demo reel, but I wanted something a little more robust in terms of being able to light it and texture it and kind of animate it the way I wanted to. So the idea was to take this kind of idea from 2D and kind of throw it into a 3D environment, and this is kind of the result that we ended up with here. So what I'm going to do is I'm going to take you through step by step on how to build it. As I mentioned, it is a thinking particle system, so I'll kind of go through how I went about building all of these dynamic sets to get the particles moving the way I wanted. So yeah, let's get started. Righto, so here we are in 3ds Max. I am currently on version 2013. As long as you are using 2010 and above, this should work. I think I initially created this in version 2011 using Thinking Particles 4, but if you're on 2010 or above using TP4 or 5, you should be good to go and shouldn't have any issues. There's nothing that isn't out of the box in this setup. So I'm just going to jump over here to the actual rendered sequence that I used this effect for. I created this for my demo reel a while back, and all of these scenes you see here, I think I created 8 or 9 different scenes. They're based off the same effect. They just use different particle emitters, different wind force or space warps and seed values and whatnot to give you some different looks. But the way it works is we have these seed particles, which are represented here by these little cubes, and they just kind of float around in space and move about using wind and turbulence and whatnot. And then based on the distance between those particles, thinking particles decides whether or not to create lines. So if you have a particle A and particle B that fall within that distance threshold, then a line is created. And if they exceed that threshold, then the line is basically scaled down to 0 and doesn't work anymore. So if we look here, if we have if this is particle A, this dark blobby thing here is particle A, and this not so blobby thing is particle B, you can kind of see there's a black line here that is created between those particles. And as those particles pull apart, you can kind of see that line is stretched and becomes thinner and thinner until it eventually disappears. What is happening is thinking particles is measuring or sampling the distance between those two particles, and it is calculating whether or not it falls within that threshold. If it falls within that threshold, it scales the particle on its z-axis, which gives you the stretching. But as it stretches out, as those two particles reach that distance threshold, it's stretched out. X and Y scale is scaled down. So you're essentially seeing particles that I can see right here is a perfect example. I'll zoom in here. As I step through here, you can see that line is becoming thinner and thinner, and it's because particle A and particle B are being pulled apart. And as they're being pulled apart, the cylinder that we're using as a instance geometry node in thinking particles, it's being scaled on Z, but the X and Y are also being scaled negatively. So as it is stretched longer, it becomes thinner and thinner until it eventually breaks that distance threshold that we've set, and it is scaled to 0 and that particle is omitted. So we're going to jump back into 3ds Max here and get started. Now the first thing we have to do is we need to create a couple pieces of geo to drive our particles. So we're going to create a geosphere here. I'm just going to zoom out here. Now this is, I gave it a radius of 60. I'm just basing that on the previous scene files that I used to set this up. It could be 60, it could be 120, you know, whatever works. You can always adjust it in thinking particles later anyway to increase or decrease our threshold, so we should be good in that regard. And the next thing we want to do is create a small cylinder, and this is what is going to be used later on to create our lines. And we're going to use this as an instance piece of geo to create our lines. So again, I'm just using values that worked in my previous setup, so a radius of 0.5 and a height of 4. And then the last piece of geo we want to create is the awesome possum torus knot. So the reason I chose this is just an object that offers a bit of complexity, so it allows us to kind of, we're going to use this later on to give a goal for our particles to kind of go towards and follow the surface. So it's just going to give our particles a bit of organic kind of dynamic motion, and it offers a little bit of coolness to the scene. So we're going to hide that. I'm going to go to wireframe, and I'm going to create another layer. I'm just going to go FX, and we're going to drop our thinking particles node onto that. I'm going to zero that fella out as well, so everything is at 0, 0. And now I'm going to open up our properties window here, drag it over. I'm going to make this a bit smaller here because I'm only operating on one screen for this tutorial, so I want everybody to see what's going on. Now the first set we need to create is our Born set. So this is where we're going to create our particles. So the first thing we're going to do, we're going to hit Tab, we're going to create a node, because we want to create particles on the volume, inside the volume of our geosphere here. Hit Tab again, we're going to go volume, do a volume position, go node to node on that. We want to be inside that, and then we're going to go position Born. We're going to use our position to drive our particle position here. So if we scrub through, right now we have nothing because we haven't chosen our node. So we're going to go pick node and drag. We should have some particles. So I'm going to run up and turn off edit on the fly. I'm just going to turn on show mesh, so later on we can kind of not have to worry about that. Our lifespan, I'm just going to jump down in here to our time configuration. I always like working in film, so I always change that. Unless I'm working on TV, then it's NTSC. So I'm going to go film 100 frames. Should be good enough. We're going to do a pistol shot. We'll say 125. Give it a lifespan of something that matches our timeline here. So I think it's 101 because we're starting at frame 0. Which is good. Okay, so now our particles are lasting the full length of our time slider here. Now we can see they're going up. We kind of want them to go up, like in all directions. So what we're going to do, we're going to change the speed to 20 just to give them a little more velocity. We're also going to go down here to our direction, keep it at 1. We're going to change this variation to 180. And what that's going to do is it's just going to take those particles and kind of spit them out in all directions, which is what we want. So with that being done, oh, one more thing, we have to throw these guys into a group as well. So I'm just going to call these, call them seeds. Select our position Born and drop them into seed. So there we go. Now the next step is where all the magic happens. So we're going to call this guy lines. I'm just going to expand this out a bit because this one is a little more involved than our Born dynamic set. So this is based off of, we're going to use a PPass AB node. So we're going to sample the distance between particle A and particle B within this group here. So we want to go to group A, we want to choose seeds for both. We're going to use our distance. Because we're using distance, we're going to create a distance threshold. So we're going to choose distance. We're going to pipe our particle A into P1 and B into P2. So this first step is calculating the distance. So we need to set our threshold and sample the distance in between our particles here, which is this value here. But we can't do that until we expose this value here. So I'm going to hit Tab again. We're going to add an integer here. And this value is going to represent our the radius of our threshold. So for now I'm just going to call it distance threshold. Pipe our distance into there. And I want to take this value and we're going to divide it by this value. And this is going to help in determining our x and y scale as our lines are being pulled apart, so it's going to scale them down on x and y. So what we need to do is take this, we're going to go helpers, math, add, multiply, take that value and we're going to divide it by this value here. So we want a divided by b. So that's our first step. Oops. Now the second step is we actually have to take into account the shape and the scale of our cylinder here, which we're going to use as a geo instance. So I'm going to add a float node here, and because, scale this over here, the height of our cylinder is currently at 4, so I want this to be 4. So I'm going to rename this so I know what it is. So I'll call this cylinder height. Oops, I'll learn how to spell first. And we need to take this distance and divide it by this distance. So we need another add multiply here. Value a is this distance. We're going to divide by this distance. And we're going to use this value here to control the z scale of our cylinder as it's being stretched out between these two particles. So we need to create a scale node here. And because we are operating x and y and z on different values, we're going to expose 3 of those. Alright, so we're going to take the resulting value of dividing our distance by our cylinder height and pipe that into our z scale. So that's essentially going to control the scaling, the length or the scaling of our cylinder between particle A and particle B. So jump back in here. So next we have one more little piece of code we've got to throw in here to account for the x and y scale. So we're going to add in a float here, and this is going to act as our, we'll call this our cylinder scale threshold. So thinking particles needs to know what the default scale is of our cylinder. So I'm going to add in, we'll go helpers, math, add, multiply. Except this time we're going to take this value and we're going to subtract the result of this value from it. So we're going to go value A to value B. We're going to go A minus B. So we kind of know what's going on, A to B. And then these values are going to drive our x and y scale here. So just move everything into place here so we can kind of see what's going on. So we have our particles being read in. We set up a distance threshold here. We follow this logic this way. So this is going to control our x and y. We take this distance and the cylinder height and we divide them, and that's going to control our z scale here. So we have a couple more steps we have left to do here. One is we actually have to create the particles that are going to be born between these two particles, A and B. So we need to create a generator position born. I'm going to throw those guys into their own group here so we can control them later on. Call these lines, I guess. Drop them into lines. We'll do a pistol shot of one particle. We'll do a lifespan of just 1, and we'll turn off speed for now. We're also going to do per call as well, so it kind of evaluates it per call. So we need to take these born particles, we're going to throw them in the scale. We also need to align these new particles to our particle A and B. So we're going to go standard alignment, and we're going to use these born particles here. So now we want to create them on our A particle, so that's going to go there. Our B particle is the 2 particle. Now one last step we have to do is we need some sort of expression in here that can be evaluated to tell this, this, and this to be on. So I'm going to expose their on inputs here. I'm just going to create a simple expression. And it's going to pop up this warning just because there is no expression in there. I'm just going to throw the expression in there so we know it doesn't pop up again. So we have A is greater than B, which is going to refer to A particle versus B particle. So I'm going to add 2 scalar inputs. Call one A. Okay, A greater than B. Oops. For some reason it didn't stick last time. There we go. So did it stick? There we go. Okay, so we'll add another scalar input. We'll call him B. And then last but not least, we're going to add an output scalar value. And we'll just call it A is greater than B. So we're going to pipe in our A particle to A, B particle to B. And now we're going to use this expression to turn this on, our alignment and our scale. So we're just going to try that to there, pipe that over there, pipe that over there. And we should be good. So I'm just going to kind of look through here and make sure everything is as it should be. So we are dividing this by that. Subtract this from that. And then we're going to use our cylinder height and divide that into that. And the last thing I want to do, I want to align them to the particle. I don't want them to be randomly aligned. So that should be good. Make sure that goes in the group. Alright. So I'm going to minimize that. And the next step is we need to get some geometry in there so we can kind of see, let's call it geo instance for now. So we can kind of see what our particles are doing. So I'm going to add in our seeds group, our lines group here. Now for our seeds, which are, go back to this, just these little cubes that you see, I'm just going to use a standard, what do I want, standard shape node here. Put those into there. Go cubes. So we got cubes in our viewport, which is good. I'm also going to add a scale node as well. So I can just kind of scale these up and get them looking the way we need to. We'll try 250. You can also see, I'm going to hide our geosphere here so we can kind of see what's going on. All of our cubes right now are kind of aligned to the same direction. So to add a bit of randomness to them, I'm just going to go back to our Born dynamic set here. I'm going to expose alignment. I'm going to take the alignment of the sphere and there, so we can kind of see now they're kind of aligning, a little more randomness to them, which is what we want. So our seeds are working well. Next we have to do our geom instance here. So I'm going to pull that across, join those guys up, and now we want to pick our cylinder here. So if we scrub through, are we getting any lines? We are not getting any lines. So let's see. Let's jump back in here and see what's happening. So our position born, they're going into lines, which is good. Show mesh. It should be showing that. Oh, okay. Here's why it's not showing anything. Right now, our distance threshold is set at 0. So all particles are going to be outside of that, so no lines are going to be created. But hopefully, if I increase this value, we should start seeing lines being created between our particles. So as I up this value, you can kind of see these lines being created here, which is exactly what we want. Now the only thing I'm seeing is, the only thing I'm not seeing, sorry, is that all of these lines are the same width. We're not getting any scaling, so something is awry in our setup here. I'm just going to go back and check this out. Let's see, what do we got here? So we have our cylinder height, added, multiply, scale thread, there we go. So this should be a value of 1, not 0. So that should resolve this, there we go. So that should resolve the issue of our cylinders not working properly. So now they seem to be doing what we want. You know, we got our cubes moving around, we got some lines being created, and then you can kind of see, I'm just going to go back a couple frames here. If you watch this line here, I'm going to step through frame by frame. As it's being pulled longer and longer, you can see they're becoming thinner and thinner. So as the z increases, x and y is decreasing. So as those particles pull apart, we're getting those lines becoming thinner and thinner. So the last step we're going to do is we're just going to add kind of a target object for these particles to go to. We do that by creating another dynamic set. Go create, we'll call this one, we'll call it forces, I guess. And we're going to drag this down. So we're going to add some movement to our seed particles here. I'm just going to throw in a standard force, and then we're going to throw in a node and a surface follow. So this is where our torus comes into play here. So before I do that, I'm going to turn this off. I'm going to unhide our little torus guy here. And I want to add a bit of animation to this. So I'm just going to go in and add a bit of rotation to it. See if this does anything. Alright, looks good. Bring up our properties window. I'm just going to choose our torus here. So now I can hide that. Turn things on again. I'm actually going to turn the lines off too, just so I can kind of see what's going on without having to wait. So we kind of got, I think everything's hooked up yet, so we're going to drag him there, go node to floor node. Now let's see what that looks like. So now we got our particles kind of flowing over the surface. So if I unhide our torus knot here, go into shaded mode, you can kind of see the particles are following the surface of our torus, which is kind of cool. So hide that. This back up. I'm actually going to get rid of that force. I don't think we need it. Do a distance of 0.5. As I increase that distance, you can see the particles are moving around. You can play around with this, whatever works, whatever suits your fancy. And then I'm also going to add some distance variation here. I'll go 51. I'm actually going to not use that, but I am going to use helpers, math, some random to control our alignment speed. So right now, a value of 1. I'm just going to minimize things here. See what happens. Yeah, we'll just try that. Whatever works. Whatever makes you happy. Alright, so we're going to turn this back on. This might take a second depending on what your threshold is set at. So if we go back to frame 0, we kind of start out with this spherical kind of looking object, and then as we kind of snaps into our torus shape, as we move around, these lines are being created based on our distance threshold. So if we want to add more lines, just go back here, take our distance threshold, pump it up to 50, and that's going to add more lines between. It may take a second here to kind of update because we're creating a lot more line particles between our cubes. So yeah, you can see that's a lot of lines. So that's obviously going to be a little intensive to render and cache out, but it looks kind of cool. I'm actually going to drop that down. We'll say drop it maybe down to 40. And then I'm just going to cache this out. So here's the current setup that has been rendered out through Preview and Max. So you kind of get the idea. I mean, things are kind of moving kind of fast, so you can kind of slow the movement down and use a drag, space warp, or you can increase the amount of particles so you get more lines being created and whatnot. But that's the general idea. So if you guys have any questions or any comments, do let me know. I am going to offer the scene file for $4.99 on the website. So if you don't want to recreate it, you kind of want to open it up and poke around for yourself, feel free to do that. But so have fun with it. Come up with some cool stuff. And if you have any questions, just let me know. Thanks again.